Hello, on this video I want to give a brief introduction to C++ classes. And the agenda for this video is I'm going to create a class with the header and implementation files, and then I'm going to create some private and public members, constructor, const functions, and mutable data members. So for that, I'm going to open Visual Studio, and then I'm going to create a project. I'm going to click on Create a New Project. Search for C++, and then I'm going to click on Console App. And then Visual Studio creates a project for me. So I'm going to delete some of these comments. And now I'm going to run just to make sure everything is good. And when I run, I get the hello world. So that means it's good. And now I'm going to create a class. So to create a class, I'm going to right click right here on source files, then add a class, and then on the name, I'm going to give it a name. So my class name is going to be car. I'm going to add, and then that creates two files for me. One is the car.cpp, and this is where you're going to implement all of your functions. And then you have a car.h. So this is your header file. This is where you put all of your class members, your variables, and your functions. So when I create a variable here, let's say int age, so this gets created as a private by default. So this is private by default. So right now, if I try to instantiate this class and use the age variable, it's gonna give me an error. So I'm gonna come here and I'm gonna try to instantiate now the car object. So car, my car equals new car. So if I try to instantiate a object like that, it's gonna give me an error. And this error here pretty much says, hey, I don't know what car is. So your main file does not know what car is because we have not included the car class into this main program. So to include, I'm going to use the include and then the car.header. And then once I do that, now he understands that this car here is from this car class. So now here everything is good. And then I'm going to run just to make sure everything runs fine. And it does. Nothing happens because I'm not doing anything to it yet. Now remember that this variable here is actually private. And if the variable is private, that means only the CPP file can see it. Any class or any other class or any other function, in this case the main function, cannot see, cannot access the variable. So if I try to access the variable, it won't let me. So even if I try to type the age right here, it's going to give me an error saying the car is inaccessible. So you cannot reach that because the age is private. Now, I do not like to create variables this way. I like to always put the keyword private right here, and that tells me that this is actually private. However, this code and this code are exactly the same. There's no difference. However, just for organizing purpose, I like to put the word private there. All right, so the other access is the public. So I'm gonna put public right here, and then anything that I declare under public, well, it is public. So public means it can be seen by the car class, and it can also be seen by any other class that implements that class. So I'm gonna put here a int size. So this is public because there's a word public right here. And because it's public, I can access that from my main function. So now size is accessible from the main function from my CPP file. And I can also do a cout here. And I cannot do cout right now, so I'm going to hover over, show potential fixes, and I'm going to add using namespace standard, which will be added right here on the top. So I'm going to click add, and now I can run this code. So let me run this code. And when I run, it prints 0. Well, it prints 0 because I have not set any value for age yet. So you can set the value for age and size here. So let's say size equals 21. So I can do that, and when I run here, this is going to print 21. Or we can find a more elegant way to do this. And a more elegant way is by creating a constructor. So to create a constructor, I'm just going to type car here and then parentheses. That's it. So this is my constructor. Now as soon as I create the constructor, I have a green squiggly right here. And this green squiggly says the function definition for car was not found. So that means I created the constructor right here, and the constructor is not implemented on the CPP file. So because it's not implemented on the CPP file, we have to implement that. So 2 ways for us to do that. You can come here and type your code manually, or you can let Visual Studio help doing that. So I prefer doing the lazy way, to let Visual Studio create that for me. So I'm going to hover over in the car, and then I'm going to show potential fixes. And then there's 2 options. One, to copy the signature. I don't want that. I want to create the definition. So once I click that, it creates that for me. So this is the constructor. So the constructor is called every time you initialize this class, or every time you instantiate an object of this class, the constructor gets called. So every time you instantiate this class, the car constructor gets called. So on the main class, when I call the new operator, that's when this constructor gets called. So over here, I can do anything I want to do. I can cout hello mom. I'm going to hover over to fix the include IO stream, and also to use the namespace standard. You can type this, or you can use Visual Studio to type that for you. Alright, so every time I instantiate the class, this car gets called. So I'm going to go back to my main program. I'm going to comment this out, and you're going to see that if I do not call this, and I just run this program, nothing happens. The constructor did not get called. But if I initialize the class with the new operator, now that constructor gets called. And the constructor right now is just printing hello mom. Alright, so let's move on. When I come here to the CPP class, I look at the card, there's a green squiggly there. So I'm going to hover over in the green squiggly, and it's saying here that there's a variable that is initialized, and it's always a good behavior to initialize your C++ variable. So right here I have variable age and size. So size is already initialized, but this is not always a good thing to do. So I'm going to remove this guy here, And then I'm gonna go back to my car implementation, and I'm gonna initialize those two variables. So one was the age. I'm gonna put age equals 21, and the other one was the size. So I'm gonna put size equals 10. So once I initialize both variables, the green squiggly goes away right here. Make sure you save your files. So every time now that I call the new car, I'm calling the constructor, and the constructor will initialize the two variables that I have. So I'm going to delete this because I don't need this anymore. So this is my constructor. Now, a class can have more than one constructor. So let's say I want to have another constructor right here. And this constructor is going to receive a variable. So it receives a parameter. In this case, it receives one integer only as a parameter. So once I create this, it gives me a green squiggly here. So I'm going to hover over. It says, hey, the function definition is not found because guess what? We have not created a function here. We have not created the constructor here. So the constructor is a function. So I'm going to do hover over, show potential fixes, and I'm going to create a definition for car in car.cpp. Then I come right here, and then this constructor gets created. Notice that the constructor does receive a variable here, a parameter, but now I need to name this. So I'm going to name this X. Notice that right here on your header, you do not need to name. You just need the data type. So back to my car.cpp file. So now I have the X, and I have a squiggly right here, and it says again, hey, you're not initializing your variables. So I need to do something similar to this. But because I'm receiving a parameter right here, I can just put, hey, X right here, and then here I can put 10 plus X. And once I do that, that green squiggly goes away. That means I'm initializing the values of car with the X, which is an integer passed as a parameter. So I'm going to put a cout here just to say constructor with no parameters. And then here I'm going to put constructor with one parameter. So back to my main class, when I initialize a class using the default constructor or the constructor with no parameters, I'm going to call this constructor. And if I pass a value, I'm going to call this constructor right here. So currently I'm passing nothing here, no parameters. So if I run this program, it's going to call the constructor that says no parameters. However, if I decide to pass a value here, let's say 3, because I have a value here, in this case 3, when I initialize this class, it will call the constructor with one parameter, which is this constructor here. So I'm going to run this program again, and then I have, hey, constructor with one parameter. Now you can do this with multiple cases. So let's say I want a constructor now that has two integers. So int and int. Two parameters. So now I have a car constructor that receives two parameters. I can do exactly the same, show potential fix, create a definition. Here I have a car that has two integers. I have to name those though. So this is going to be int x, and this is going to be int y. Now I have the green squiggly here again. That's because I have not initialized those values. So I'm going to initialize those values right here. So the age is going to get X and the size is going to get Y. And then I'm going to put another message right here. Say, hey, constructor that receive two parameters. So now if I call this function, I pass 3 and let's say 5, then this automatically will call the constructor that has two parameters. So running this guy, and I call the constructor has two parameters. Now you can keep on going forever right here. You can create as many constructor as you want. You create a constructor that has a int and a string, for example. No problem whatsoever. You can do that as well. So I want to remove that string, and I'm going to move on to the next topic. All right, so now that we have created all this constructor, I want to create a couple of functions on this class. So I'm going to create a function here called voids doit. The void doit is going to do something. So I want to hover over, show potential fix creates the function. So this here is a public function, and this public function does something. So from the main program, I can use my object and then call the doit function. And the doit function, all it does for now, it just prints the age of the car class. So I'm gonna run the program and it prints 3. 3 is the age. All right, now if you notice on the beginning of the doit function, you have 3 dots right here. If I create a function that changes the value, so I'm gonna age plus plus. So this function right here is also a public function, but this function is changing a member of the class, changing the value of the member of the class. So if you look at this function, doit, it has the 3 dots, and this function does not have the 3 dots. And I'm talking about the 3 dots right underneath the letters D, E, and O. So the letter D and O here do not have the 3 dots. So I want to hover over, and it's saying here, hey, this member can be made a const. So a const function is a function that does not change any value within the class. So this function is not changing any value. This function here is changing a value. So because of that, this function cannot be made into a const function, but this one here can. So I'm gonna click on show potential fixes and make member a constant. So now the word const got placed right here, and the same thing happened in the header file. The word const got placed right here. All right, so I am seeing a green squiggly right here on the doit function. However, this is correct because when I look at the implementation, I look at the doit and it looks fine. So this is correct, but it's still giving a problem right here. Not a problem, but a potential fix. I think I found a bug with Visual Studio. Anyway, I want to keep going. I know this is correct, so let's test if it works properly. So I'm gonna just print the age right here on the doit const function, and the doit2 is going to print doit2. So the doit is a constant function, so because of that, the doit cannot change any value. So if I try to change a value here, it will give me an error. It will not let me do this. So the const function cannot modify the value. However, if you change the age into a mutable variable, now because it's mutable, because it has a mutable keyword right here on the age, now your const function is able to change the age. So remember, a const function cannot change any value unless the value is declared as mutable. So now age is mutable, and therefore the const function can change the age. So now I'm going to duplicate this function here. However, I am going to remove the const word here. So once I remove the const word, this function now is a overload of the const function. So I also have to implement this function. So the doIt function is a overload, so I can have two of those, but I need to remove the const from here. So this const function is a copy of the non-const function. So both of them can change the age in this situation because the age is mutable. If the age were not mutable, then the const function would not be able to change the age. So I'm going to remove the age, and then here I'm going to replace the age with the doIt const function, and now I'm going to replace this here with the doIt non-const function. Now the reason I want to do that is to show you how do I call this function that's const, or how I call this function that's not const. They have exactly the same name. So how do I differentiate if I'm calling this function or this function? So whenever you create the object, so this object here is a non-const object. So because of that, when you call the doIt, it's gonna call the non-const doIt, which is this function right here. So I'm gonna run, and it calls the non-const doIt function. Now if I create another object just like this one here, but I use the word const right here, and then I call the doIt function, then this function call here will call the constant version of it. So this will call the non-constant, this will call the constant. So let's run this program, and now you notice right here that the first call, which is right here on line 11, called the non-const function because this is a non-const object. So the second time I call the doIt function on line 14, because I'm using a constant object, now it called the constant function. So this is how you differentiate which function you're calling when you have a overloaded function and one is a const, the other one is not a const. Alright, so that's all for this video. Thanks for watching.